Hello everyone, welcome to DJI Geospatial Solutions Training. Today we are going to talk about the outputs and deliverables. This is the content of this course, so we will talk about the 2D and 3D deliverables and the application deliverables. Okay, let's get started. So with the development of surveying and computer technology, so maps are no longer limited to the traditional paper-based display mode. So modern digital maps are mainly consist of DEM, DSM, DOM, DRG, and composite mode. First is the DEM. So it refers to digital elevation model. Is used to express the spatial distribution of terrain, so mainly used to describe the terrain undulation. So DEM is an elevation model that it has removed the vegetation, artificial buildings, and other land features. So it can be used as a long-term surveying result for storage. And it can be widely used in many industries such as surveying, geology, engineering and construction, and the communication field. And how to get the DEM? So usually we could use the photogrammetry or LiDAR. In photogrammetry workflow, after the images are taken by drone, so we can use DJI Terra to do the 2D reconstruction to get generate the DSM and generating the DEM using third-party software. And in the LiDAR processing, so we could actually is during the process of generating the last point cloud when we're using the L2 plus DJI Terra, so DEM can be directly generated based on classified ground points. Another important part is how to obtain the public DEM files. At present, the public available DEMs are mainly have resolutions of 90 meters, 30 meters, and 12.5 meters, which can be publicly downloaded online. And DJI Pilot software also has a built-in download function. But to be attention that the public DEMs may have significant errors. So if you are used for terrain following flights, the accuracy of the DEM needs to be ensured. So in this way, we were highly recommended that we use the DSM for terrain following flights. But what is DSM? Actually, it refers to the digital service model. It's a surface elevation model that includes the vegetation, artificial buildings, and other features. So in the drone photogrammetry, we could directly generate the DSM, which has strongly time constraints. So DSM is a more realistic representing of the surface undulation, so it can be widely applied in various industries, for example, in forest area, in urban area, and so on. And next result is the DOM. It refers to the digital orthophoto map. It uses DEMs to correct pixel by pixel projection difference in aerial image. So with map geographic information, with map geometric accuracy and image features. Each pixel has longitude and latitude coordinates, all with the geographic coordinate information. DOM is a parallel projection of orthographic views. It means the building facades cannot be seen. And with drone, we could also produce the digital true projective images. We call it TDOM, which are corrected through differential correction using the DSM for more accurate. And I have attached a live photo to show the difference between the DOM and the original photo. You can see, as the original photo, the building facades can be seen, but as the DOM, it will totally be a vertical view and we cannot see the facades. Okay, and the next output is the DLG. it refers to the digital line graphic. It's a vertical dataset of various map features that are basically consistent with existing line marking and preserves the spatial relationship and attributes information between each features. So DLG is ultimately results of field surveying and mapping. So whether you are using photogrammetry or using the LiDAR, we are finally, so DLG is the final results that the end user need. The required accuracy of survey and mapping results is all for DLG. This is very important. So it's related to the accuracy of the model itself and also related to the drawing accuracy of the line drawing. And how to produce the DLG? So currently, visual inspection and manual mapping is commonly used in the drone aerial surveying. We could generate it through DSM plus DOM, or we could generate the DLG through 3D models. And I have attached a video and a photo to show how to use the third-party software to create the DLG based on 3D model. Usually, we drawing the line based on 3D model, and at the same time, the DLG line will automatically show in the right. So this is the final result. As you can see, it's very easy for the end user to draw these lines nowadays. Okay, next part is the 3D deliverables. First is the point cloud. So in photogrammetry, the point cloud refers to a collection of points extracted from image data using 3D reconstruction technologies. And each point in the point cloud has its own 3D coordinates. Usually it's X, Y, and Z, but may also include other attributes information such as color, as intensity, and so on. So point cloud is a discrete representation of the surface objects or seen in the 3D space, and is widely used for various 3D model and analysis tasks. And it's very interesting. So why point cloud is so important? So I have attached a case that, for example, we use the traditional measuring instrument. There's a total station here to obtain multiple single point to an object. But can you distinguish what object is being measured? So although we have measured lots of points here, but can you distinguish what kind of target or what kind of object are we measuring? Obviously, it's very hard for us. Okay, so if we use the point cloud technology, we can totally see. So using point cloud data to present the objects compared to the traditional measures, so it will be more intuitive. Next output is the mesh. A mesh model is one of the important outcomes in oblique photogrammetry. Is a type of 3D geometric model composed of many small polygons, usually with triangles. So these polygons collectively form a continuous surface that can accurately represent the terrain, buildings, and other ground features. So to help you better understand what is mesh model, so I have attached several screenshots. Okay, first is, so the first picture is a 3D model, originally 3D model. So next, let's combine the mesh model and the 3D model together, as you can see. So actually, this model are composed by lots of small triangles. So next part, let's moving the model away. So just keep the mesh, as you can see. Either the target is big or small. So usually, it all composed by the triangles. Okay, let's switch to another view so you can see, yes, all objects are composed by the 3D by the triangles. So just in different views. Okay. And the process of generating a mesh model typically includes the following steps. So first is the image acquisition. I believe you already know. So we use the drone to capture raw data. Okay, and the second step is image processing. We could use the DJI Terra to process this image, including the type point extraction, the matching, and the 3D reconstruction. So the next part is the point cloud generation. So generating a dense point cloud dataset through the image matching and 3D reconstruction technology, where each point has 3D coordinates. And after that, we can do the mesh generation. So we're converting the point cloud data into a mesh model, which usually involves a triangulation process, etc. So connecting the points in the point cloud in a triangle mesh. And the last part is do the texture mapping. So mapping the color information from the original image onto the surface of the mesh model, so then the model not only has the geometric shapes, but also has the realistic texture and colors. Okay, and the last part is the application deliverables. So there are also some outcomes that we have to pay attention to. The first one is the DXF. It's a drawing exchange format. DXF is a file format developed by Autodesk, so it's a very famous company, for exchanging the 2D and 3D geographic data between different CAD software. So the DXF file was originally designed for AutoCAD software, but due to its openness and widely support, so now it has now become a common exchange format among many CAD applications. And by the way, I believe you all more or less had heard this word. Is there the DWG? So DWG actually is a native format of Autodesk from the AutoCAD, while the DXF is an open CAD data format. But these two formats can convert to each other as needed. Next is a counterline. A counterline is a line on the map that represents the points of equal elevation. So each counterline connects the points that have the same altitude. The density reflects the steepness of the terrain. So the closer of the counterline are to each other, it means the steeper of the terrain. And the more space out of the counterline, it means the gentler of the terrain. So you can see in the middle of the two hills, so you can see it's more steeper. It's more steeper over it to the line, so more close to the line. So it means is more deeper of the terrain. And the counterline has widely application in fields such as geographic, engineering, environmental science. So for example, on the topographic maps, the counterline can help engineers design the location of roads, bridges, and buildings. And the topographic maps usually also mark some key elevation to make it easier to understand of the specific terrain. So the vertical distance between the counterline is called the counter interval. So you can see I have marked here, and this distance is fixed on the map, but the specific value of the counter interval, it will depend on the map's scale and purpose. So either it's 10 meters or 50 meters, it really depends on the customer's need. And I have attached several photos to show what its counterline looks like. So this is the original colorized point cloud, and this is a combination with the colorized point cloud plus counterline. And there is a DM with plus counterline, and this is the originally counterline. By the way, DJI Terra can generate the counterline directly as long as you enable the counterline button. Okay, another is the shape. It's a shape file. It's a vector data format used in geographic information system developed by Esri. The shapefile format is widely used for storing the geospatial data such as points, lines, and polygons, as well as the attributes data associated with these geometric shapes. And it has some some function, for example, the widely supported, easy to use, and with efficiency. And by the way, so when generating the content line, so Terra can also output with the content line with the shape format, and I have listed a real case here. The last output is XML file. So in the context of the photogrammetry delivered 3D model output, XML file is typically used to store and transmit the metadata and the configuration information related to the 3D model. And it has the following purpose. First is the metadata storage. So XML file can store the metadata related to the 3D model, such as the creation time, creator, coordinate system, projection information, resolution, etc. So this information is crucial for subsequent data processing and analyze. So the second purpose is it can do the model structure description. So XML file can describe the structure of the 3D model, including the heritage relationship, names, attributes, or various parts. For example, a complex building model may consist of multiple parts, and an XML file can describe the relationship between these parts. XML file can also do the data indexing and referencing. So in some cases, the data of 3D model may be distributed across multiple files. So XML file can be used to index and reference these data files. For example, a large 3D model may be divided into multiple blocks, so each stored in a separate file. And an XML file can record the paths and related information for these files. Another is the parameter configuration. So XML file can be used to store parameter configuration related to the 3D model processing, such as rendering parameter, texture mapping parameter, lighting setting, etc. So these parameters can be used in subsequent rendering and display process. The next function is the data exchange. So XML is a standardized data format that can facilitate data exchange between different software and system. So during the processing and application of 3D model, XML file can be served as an intermediate format for transforming data between different tools and platforms. The last function is do the annotation and comments. So XML file can be used to add annotation and comments to a 3D model, such as geographic location of a point, the attribute of a region, etc. So this information can be stored in the XML file. Okay, this is the end of the outputs and deliverables. So hoping this course could be helpful for you, and let's continue meeting you in other courses. Okay, see you. Bye.